here to tell you about all these technical things which we use to make computer games. Our topic for today is lights. Thank you. Now, we need lights in our game so we can see things, obviously. But lights can also add mood and suspense to our game. They can also be useful for, special effects, the sort of things, don't you? Now, let's talk about the various types of light. No, I don't mean these sorts. Within the computer graphics, lights are basically divided down into four main types: ambient, directional, point, and spotlights. We'll be talking about each of them in turn in a while. Consider a sunny day. When you're in the shade, there is still light. You may not be able to see the sun, but there's still some light there, somehow. Now, the physicists will tell us that there's some complicated thing about light bouncing around and, well, the light gets everywhere. This is known as ambient light. It's called ambient because it lights everything equally. You get ambient light basically everywhere, even at night. Unless, of course, you are deep underground and you have no light source, in which case, well, you can't see anything, can you? Let's go back to our sunny day example. If you consider all the objects in our game, all of them are getting lit up on the same side. This is caused by a directional light, the sun. If you consider this, all the parts that face towards the sun are brightly lit up. Those that are away from the sun get nothing, and that stuff which is partially towards the sun gets some of the light. You get the idea. Again, our friends the mathematicians and those who study all this complicated theory of computer graphics will explain to you that actually the directional lighting computation is very simple to do, but for our simple perspective, all we really need to know is that directional lighting and a bit of ambient lighting will give you quite a good job for the effort you put in. As for point lights and spotlights, well, they're basically lights, but they have a position, and in the case of a spotlight, it's also got a direction. The other attribute they both have is a range. Within this distance, you can see them. Outside of that distance, it's dark. On top of this range, it's quite common for lights to get less strong the further you get away. So the objects which are nearer the light source are brighter, and the objects which are further away get dimmer and dimmer. This is known as attenuation. There are a few various ways to compute it, and everybody uses a different system. DirectX uses this rather complicated equation here, where d is the distance between the light and what it's showing. This is probably going to cause several of you migraines, so we won't go into too much detail on this bit. The other feature, which is found only on spotlights, is, of course, how wide or how narrow the beam is. If you've got a very narrow beam, you don't see much. If it's a very wide beam, you see a lot more. The second key feature is the materials. I'm not going through what a material isn't. Let's talk about what a material is. Basically, it's the color, the texture, and the specular. More on that later. Now, whichever modeling software you choose to use, 3D Studio Max, Maya, doesn't matter, they all have roughly the same concept behind them. I'm here teaching you technical things. I'm not going to teach you how or how not to draw. That's not the area I'm here for. First and foremost, color. If it's a simple object, we go for color. Most of the time we don't bother, and we go straight on to texture. Now, there's lots of complicated stuff on how to get the texture, how to put it on the object. Not going there. You know it's done. Go look it up in a book or something. The other thing is the shininess. We all know what shininess is. Within the computer graphics world, they call it specular. Now, usually the specular is white. It looks nice. The other attribute you have to set, at least within DirectX, is called the power. The power basically means how shiny. If it's a low power object, it's a larger highlight. If it's a very high power, it's a smaller highlight. It looks shinier. Just make sure when you're doing your modeling that you get this shininess attribute sorted out. Otherwise, you get some really unnatural looking effects like this. You notice I haven't said a word about shadows. The reason is simple. No, it's not because of a vampire or anything like that. It's simply put, the lighting algorithms don't give shadows, they just give a nice 3D effect. The shadows is extra code, means more work. We're not going to do it. Let's move on to how to use lights. Well, here's what I want you to do. Go and play some games. Not just anyhow play, but pay attention to how they've been using the lights, or how they're not using the lights in a bad case. Learn from them, see what works, what doesn't. If you want just simple lighting, an ambient and a handful of directionals will give you good, simple lights. Just tweak the ambient level. If you have ambient too low, it gets rather dark. Ambient too high, it gets too bright. If you put too many lights on the scene, well, you know what happens. On top of this, you can add in your spotlights and your point lights to add in nice effects. Part 4, we're going to talk about coding it. Now, by now, some of you are probably struggling to stay awake, so I'm going to try and keep this as short as possible. If you're working with one of the innumerable games engines, basically, read the manual. I'm not going to try and tell you what your particular game engine does, but chances are extremely high that all the game engines you'll use will have these basic concepts in them. If you're working XNA, DirectX 11, any of the shader languages, or any of these sort of things, basically, you're on your own. It's going to be hard work, so be prepared for a lot of pain before you get it working nicely. I'm going to talk now about how to get it running for DirectX 9, which is pretty straightforward. Ambient lighting, really easy. You just get a color, and you tell the DirectX device, this is the ambient color I want. Simple, 2 lines of code. For all the other lights, DirectX has a structure called D3D Light 9. You get it, you fill in all the details, you hand it over to DirectX, and it will take it from there. The DirectX 9 lighting structure is a complicated little beast with heaps of attributes, many of which you don't actually need for all the various light types. So I'm just going to give you the quick summary on the main bits you need to be aware of. The type, point light, spotlight, directional light. Enough said. Diffuse color, whatever color you want your light. You want a pink light? Go for it. You want a blue light? You know. And so on. Specular, usually they're white. The ambient attribute, just ignore it. Position, I'll let you figure that one out. Direction, that's for your directional and your spotlight. Again, straightforward. Just make sure it's normalized, otherwise the mathematics goes a little bit strange and you get some really weird light effects. Range, again, enough said. Fallout, this is something for spotlights only. Just put it to 1 and leave it alone. The theta and the thigh is also for spotlights. It's all about the angles. Read the textbook. Attenuation, this is used on directional and spotlights to make the light fade off neatly. I've put up some values. Try it, mess around with them, see what works for you. So, here's the quick summary. You create your light, make sure it's empty, fill it with all the various attributes, hand it over to DirectX, and there's your light. So, in conclusion, lighting is very important in your game, and oi! Turn those lights back on! Thank you! Now, where was I? Ah yes, if you don't put in the lights, it looks awful. If you put in a few directional lights and a little bit ambient, it can look just fine. If you want it to look really good, you're going to have to start experimenting with the more complicated lights to get some really nice effects on it. Other than that, happy coding!